Good afternoon. Thank you everyone for attending today's webinar, Dynamic Machine Control Through Advanced Hydraulic Valves, brought to you by Eaton and Design World magazine. Just a couple of housekeeping details before we get started. You will see several boxes on your desktop, all of which can be moved around to suit your preferences. Now initially, the Q&A box is at the lower left, and this is where you will enter your questions for the Q&A session, which will follow the main presentations today. Another box to note is the additional resources, which is initially at the lower right-hand corner of your desktop. These resources are for your information needs. We also have a tweet box right on the desktop, so feel free to tweet any interesting points right from there. And there's also a list of hashtags for you to use. My name is Paul Heaney, and I'm the editorial director for Design World and Fluid Power World magazines. A little background on me: I have a mechanical engineering degree from Georgia Tech, and I've been covering the engineering and manufacturing worlds for more than 20 years. I'm pleased to be your moderator today. I would like to take this opportunity to thank our two presenters for being here today and to introduce them. Paul Brenner has more than 25 years of experience in the fields of engineering research of ground engaging machinery and advanced hydraulic systems. Paul holds several U.S. patents and has patents pending relating to high efficiency hydraulics, hydraulic energy recovery, and system-wide diagnostics. He has held senior engineering and strategic roles within large privately owned and publicly traded companies in both Europe and North America. And Nadine Powell is a marketing and sales professional with nearly 20 years of experience developing and implementing sound marketing strategy. She's currently the Global Product Manager, Mobile Valves, for Eaton's Hydraulics business, where she drives market analysis and development to grow the company's mobile valve market share. Powell holds a Bachelor of Applied Science degree in journalism and public relations from Eastern Illinois University. And so now, without further ado, I'm going to hand the mic over to Paul.
Okay, thank you, Paul. This is Paul Brenner. So just going straight to this slide here, just a few opening comments and perceptions around this slide that will hopefully allow me to communicate Eaton's dynamic machine control approach. I don't think that anyone can deny that there is a movement in the mobile and industrial machinery markets towards smarter machines. If we work through the value chain, we can see the end users are demanding greater performance and efficiency from their equipment, and the machinery OEMs strive to exceed the customer wants and needs, while still remaining focused on improving their operational efficiency through the design process, right the way up to the point where the machine rolls off the end of the line. Distributors of hydraulic power and control systems want to differentiate with intelligent, flexible, and durable solutions. Next slide. Okay. The three headings shown here give some insight into what is driving the smarter machine movement. OEMs and machine integrators require greater flexibility and efficiency in their machine process. Typically, machines are expected to undertake a variety of duties and run an assortment of attachments while potentially operating in harsh environments across the world. The smart machine is a global machine platform, a flexible machine design that can be uploaded with a selection of advanced machine-level software applications, either on-site or remotely, thus enabling the machine to work efficiently and without compromise in all environments under various load conditions. Safety, productivity, fuel efficiency, and reliability are all key characteristics that are expected from owners and operators of off-highway machinery. Smart machines don't compromise at achieving any of these attributes. For example, application mode selection allows operators to simply choose via a press of a button the correct machine profiles needed to allow them to achieve their operational goals in a safe manner. The mobile off-highway and industrial machinery markets that Eaton serves today are evolving at a rapid pace, driven by regulation and the attributes mentioned previously, which in turn has compelled the adoption of many of the advanced technologies that can be found today in the automotive and on-highway truck markets. So the next slide So at a high level, what is dynamic machine control? Well, dynamic machine control is Eaton's approach that enables our customers in their pursuit of designing and developing smarter machines. The Eaton team has a deep understanding of complex machine and system dynamics, and this is critical when you have the goal of developing and supporting a range of advanced hydraulic products that integrate seamlessly together from both a hydraulic and electronic controls perspective. The last bullet on this slide is just as important as any product or advanced product message. A cohesive team of application experts armed with the right tools is a decisive factor that underpins the dynamic machine control approach. From the system concept phase through the various phases of development, these guys are there to support and in some cases become an extension of our customers' development and after-sales support teams throughout the life cycle of the products. The value chain for dynamic machine control resonates across our complete customer base, from our distributors who are looking for product flexibility as they endeavor to respond rapidly to demands of their customers for multiple product lines on one hand, or trying to maintain a careful control of potentially a vast inventory on the other hand. System integrators who build via their extensive knowledge of products and subsystems, bringing all the pieces of the system together and offer an end-to-end solution. And the machine manufacturers themselves, whether they are large or small, and the end user, whose bottom line is heavily dependent on their operating costs, which in turn are a reflection of the fleet's potential to be highly reliable in a productive and fuel-efficient manner. Okay. The CMA Mobile valve is one of Eaton's most advanced ProFX-ready products. It employs a twin-spool architecture that enables independent metering of the inlet flow from the pump and the returning flow from the actuator. A combination of the CAN-based vehicle system module on the front of the valve and the onboard electronics and sensing dedicated to each individual section enables software configurability to match the exact flow and pressure demands of each individual service. No more main stage spool tuning or messing around with pilot valves and springs, etc. Okay, so I'm losing track. All right, so slide 10. Eaton has a broad portfolio of software-enabled electronic and hydraulic products. These products can be easily linked together by ProFX Control, our open platform application development tool. The hardware we offer aligns perfectly with the environmental requirements of both mobile and industrial applications, built to provide reliable and safe performance. A few examples of this hardware include Eaton's line of HFX electronic controllers and VFX displays. All product categories are referenced as ProFX Ready. So what does ProFX Ready mean? Well, what this means is these products are designed to work out of the box and they can be matched easily together and work seamlessly by applying ProFX Control, greatly streamlining the process of starting the software development for your unique application. Essentially, our hydraulic products and electronic control developments are closely connected throughout the various stages of the design process. Okay, so here I'm going to hand over now to Nadeem. So I've covered a high level of our dynamic machine control methodology and then briefly touched on our ProFX Ready product approach with references to Eaton CMA Advanced Mobile Valves. Now I'm going to hand it over to Nadine, who's going to go into the technical detail and perhaps more importantly, the value proposition for this unique product line.
Thank you, Paul. Good afternoon. This is Nadine Powell. I'm the Global Product Manager for the CMA valve. You want to move forward to the next one. Today I'm going to introduce you to Eaton's next generation and advanced electrohydraulic mobile valve. As you'll see in the upcoming portion of this presentation, this valve offers unlimited possibilities to differentiate machine capabilities. Now, before we start, though, however, I'd like to give you a brief overview of some of the mechanical features to give you an understanding. Up in the right-hand corner, as you can see with the red circle around it, this is our valve system module, basically the control system, or what we like to call the brains of the entire valve bank. Right here, this is where it will maintain backup parameters of the valve. It will monitor each section of the valve, and it is the main controller of the valve. Shown in the cutaway is a cutout of our work section, which is basically where we like to say the magic happens. As you can see, there's two portions of it. There's a pilot valve and a main stage. Noting in there just a couple of the key features, one being work port pressure sensors that we have on this valve, as well as spool position sensors. We also have sensors that monitor the temperature, not noted here. And then we have what's called independent metering, which are shown in those two main metering spools. Next one. The CMA valve is CAN controlled. It's a CAN bus system. We offer two communication protocols, J1939 and a CAN open. It's available in two frame sizes. Our smaller one is the CMA 90, meaning liters per minute, and then the CMA 200. We offer at a high pressure rating of 440 bar. With the electronics capabilities of this valve, we have very fast dynamic response at 24 milliseconds at 15 center stroke. All of the valve tuning is done through software parameters, which we'll touch on a little bit more as we get into this presentation. From a mechanical standpoint, we offer two spool options for the CMA 200, high flow and a low flow spool, and then one spool option for the CMA 90, which we call our standard spool. We offer a number of different flow sharing options that you can do with regards to pump saturation. And then we have options for both variable displacement and fixed displacement pumps, although we do offer only variable displacement at this time for the CMA 90. And when you look at from environmental conditions, we offer across a wide range of temperatures. So what brings the value of the CMA 90 and CMA 200? It first starts with what we call our independent metering. And this is our twin spool architecture where we independently do meter in and meter out. So if you think of a conventional mobile valve that has one spool, obviously there's a fixed relationship when you're trying to work with both flow and pressure and that meter in and meter out relationship. With having the independent metering, we can optimize load control independent of any load conditions. We also have infinite programmable machine functionality through flow and pressure control. So the benefit that can be seen in some of our customers have seen are a reduction in metering losses and energy management. And then another byproduct of independent metering is that advanced port pressure control. As you saw in the hardware overview, we have pressure sensors in there. So we have the ability to control force on different applications and change parameters easily through software. We also have the ability to limit pressure maximums based on the application. And overall, a lot of our customers have been able to see an improved performance from that. As you also saw when you saw the hardware, with having all those sensors on it, having its own control mechanism, we really have positioned ourselves with this valve to have advanced diagnostics and servicing. One of the things I touched on briefly in the hardware was the parameter backup. Basically, that VSM is programmed and maintains the database for each one of those work sections, functions, and everything that's involved within that function and work section. And because of that parameter backup, one of the benefits from a servicing standpoint that we often see is that if you were to have an issue with one of your work sections, we have the capability to put on a new work section in the field, bleed the valve, and retrain it through the VSM, so we can get an OEM back up and running quickly. Along with having all those sensors on it, we have the capabilities for diagnostics. So anything from inlet, spool position, to consume flow and oil flow. Those are all options that are available to be monitored and can be reported out to customers through this valve. And finally, we believe that you have the capabilities to do some predictive control behavior. If you have the capabilities to monitor pressure and flow of the valve, you're getting some monitoring capabilities of other hydraulic components within the system. As I stated earlier, in this next, on the right-hand side, everything is programmed through this valve through software. So we have a number of advanced software algorithms that we have set up. Some are basic software that we offer within the package. Other are optional pieces of software. What we're doing with this valve is we really offer an OEM versatility and multi-mode functionality. And we bucket our software, and we'll look at this more in the next slide, into three really different buckets. One is force control software, which is basic software that we offer. Machine diagnostics type software that we offer that can be utilized within telematics. And then system dynamics that may be more specific to a certain application or product. So when you look at our software controls, the first one, force control software, really deals with pressure control and other things like brake control, pressure and flow control, and then torque control. And for example, and I'll just give you one, torque control is one that we currently use on a winch application to maintain the tension within the winch. In our next bucket, we look at sensor and machine diagnostics. So we have a couple unique features, one that I'll touch on called hose burst detection. Just to clarify, this does not stop a hose leak from happening, but basically because we have the ability to measure pressure and flow at all times in a real-time diagnostics, we are able to sense when there's a disruption in the flow within regards to that work section. And what will happen is the valve will throw a code, alert the operator that he has a potential hose leak, alert him to the work function that's seeing it, so he has an idea of where the potential hose leak is, and allow him an opportunity to fix the machine prior to any hose burst, which can often become an issue for somebody like in the refuse market who, if you dump a reservoir, that obviously becomes a hazmat event. And then finally, we have system dynamics. And right here, these are more unique type software features that we're offering that are specific to an application. And the one example I'll use is that boom bounce reduction. The boom bounce reduction has been developed for an industry, the concrete pump trucks. And if you know anything about that industry, they have very long chutes where they pull the concrete out and work on the construction site. And often within those chutes, you have a very large amount of vibration. Often it can cause the operator to slow down on production to ensure that the concrete is poured correctly, or it'll cause them to have workers who will have to hold ropes to hold that chute in place. We've recently tested this system dynamic software on a test truck and found a 73% reduction through software algorithms that dampen that vibration with the use of the CMA valve. So where is it used? The CMA valve we've actually had out now in prototype stage, testing on a number of applications. And what you'll see here is a number of applications that either we currently have tested on, are currently running in production, or we're currently about ready to put them on a test rig. So we are in everything from vocational trucks, which are refuse and utility trucks, all the way to ag and forestry applications, and then into more some ancillary markets like marine and oil and gas and snow grooming. So often the question we get asked with this is, obviously everything is programmed through software. It's highly technical valve. What does it entail to configure this valve and commission it to a machine? One of the things that our engineering department did a tremendous job in developing was a software system called ProFX Configure. And basically, this is a best-in-class service tool framework that will consolidate the configuration needs for all of our hydraulic products, ultimately. But right now, we are launching this currently new piece of software with the CMA. And as you can see here, we are showing some screenshots from this new ProFX Configure 2.0. Everything from utilization of detection to configuration, which is done in a very app-like type format, in a wizard type format, to diagnostics, to putting the valve and having the valve running and to be able to look at real-time response with regards to the parameters and settings that you've put in for this valve. So one of the things that we always like to talk about when it comes to this valve, with the advancement of this valve, is that our goal with this valve, and as Paul touched on with dynamic machine control and having smarter, more intelligent, productive, safe equipment, is how can we help customers solve problems? So I'm going to go over some key problems that we've been seeing with our customer base. When the opportunity arises, I'll try to touch on some key benefits that our current customer base has seen, and if we can help kind of quantify some of those benefits to you too. So the first one, obviously, with any setup or commissioning or design of a valve, we really look to the time and resources that it takes. With conventional mobile valves, you often have the problem of adjustment of school and housing during valve setup time that can sometimes take weeks to do. Because, as I stated, with the CMA, we don't have that issue because of the ability to configure via software on a laptop. So there's no spools, no changing out any mechanical parts. It's all done via software. The next one we look at is increased stability. We talk about the position sensing and the pressure sensing and the flow capabilities. When you're dealing with large loads and you're needing in a precise environment, control is really important to your operators. So we really, with our pilot valve, we're having sensors and microprocessors on them. We're able to have intelligent, precise control. The other thing, too, is there's often times where you have issues with traditional valves where you have inconsistent actuator movements when transitioning between passive and overrunning loads. Because of the independent control of meter in and meter out, we're able to smooth out those transitions between those passive and overrunning loads. Real-time diagnostics, I think we talked a little bit about the real-time diagnostics prior to that, but with all of our onboard sensors, we basically can monitor everything on that valve. We can get real-time diagnostics view of that valve and even a little bit of the hydraulic system. So it really allows you to monitor the performance, watch from a potential maintenance, and really be able to also pinpoint if there's failures in the future. Continue operation until the job is done. This is another feature that we have that was shown on a previous slide, and it's called our limp mode. Obviously, we never want to talk about a component being down, but we know realistically in the real world that happens. One of the things our engineering team has developed is a software algorithm called limp mode. And basically, if the sensor was to go down in a field, this would allow the operator to finish the job because the software algorithms alerts to the fact that one of your sensors is down, and the other sensors within that valve will take up the work at a slower rated pace, but it allows you to get your machine finish either a job that you're doing on the construction site. In this scenario, we have farmers that are very interested in it because it allows them to plant their field before a big rainstorm. and it just allows you the capabilities to continue your uptime. Improved control of movement, and we touched a little bit of this with the boom bounce, but with this twin spool architecture, the onboard sensors, the data processing capabilities of CMA, we can determine load conditions, flow demand, and available flow and implements. And we have a lot of proprietary control strategies that really help us result in infinite control for your machines. With the CMA valve, obviously when you're designing to your machine, one of your concerns is you want to maintain functionality of your machine for that operator from a productivity and a safety standpoint. And often people design their machines to eliminate any pump saturation. Usually it means you design to oversize the pump. With the CMA solution, we offer a number of proprietary flow sharing algorithms and methodology that you can utilize to avoid pump saturation completely. We can also do what we call priority methods, meaning that if there's certain functionalities on your machine that you always want to have priority from a productivity or a safety standpoint, you can maintain them. And once again, this is all done through the ability of software. Reduced inventory levels. As we talked a little bit about, there's not a lot of mechanical aspects to this valve. As stated, it's done all through software. So, we know of conventional mobile valves that offer 200 plus spools. For somebody who has hydraulic valves on their machines, that often means inventory, especially if you offer different machine specifications or options. With only having 2 spools available needed to calibrate the CMA, you don't need to have a lot of stuff on your shelf. In fact, we have current customers who have a couple pilot valves, some work sections, and they basically have their laptop, and that's all that's required for inventory. And I think the last sentence really sums it up, is it's one valve, many uses, simplified inventory. And then finally, when you look at the independent metering, one of the benefits of this is if you were to have an application, and probably the best way is to explain it through an example, is if you were to have an application with 2 unidirectional motors, obviously with a conventional mobile valve, you'd have to have 2 work sections. But with the ability to have that meter in and meter out and those 2 spools, you have the capability to do 2 services with 1 section, which means that you could eliminate a section in your current valve bank that you have. So potentially reduce a section within the valve bank for a cost out of the complete system. So now that we've told you a little bit about the valve, let's talk a little bit about a couple of our customer successes that we've had with this valve. This first one, as you can see, is a large drill rig. We work with a customer, has 43 sections per machine, so a lot of valves on there. Not a very dynamic machine, but however, has multiple pumps, multiple CAN buses. And what the CMA valve was able to do is, by utilizing our electronic load sense feature in CMA, we're able to give them a distributed hydraulics. So we were able to eliminate over a mile of hose. With the pressure sensors that we have within the valve, we were able to eliminate a number of ancillary pressure valves, pressure reducing valves that they had on the system, because it was encompassing in the CMA valve. Because we have the ability to really regulate flow, we were able to offer them some low flow metering capabilities. And then also with the valve flexibility, we touched on this briefly, we were able to use some of our 1 section configuration and use it on more than 1 service. So we actually eliminated some sections from their machine. And then when you look at this also, this customer delivers these drill rigs around the world. So one of the things they really require is 24-hour availability of spare parts for each section. So limited inventory to them. Also with our ProFX configurator, which I forgot to mention, is we have the capabilities to do remote diagnostics. So globally sending a machine anywhere. I've seen one of our engineers sit at a desk here in Eden Prairie, Minnesota, and talk to a gentleman in Canada and watch the valve as it's performing on the machine. So highly independent of having to, be there on site. You can do a lot of remote diagnostics with this valve. And then finally, I wanted to show you a more dynamic type application, and this is a snow groomer. And for any of you those that are skiers, we always like to have a smooth slope that we go down. So in the past, snow grooming, you have a lot of varying conditions, varying terrains. And what we were able to do with the CMA solution, because there was a lot of operator fatigue because they were constantly managing the machine speed and down acting pressure of the implements, is we took the operator input and combined with sensor data and logic on the valve, and we're able to shift on the fly from pressure to flow control. So a function that's nearly impossible to traditional systems can be done with the CMA. And so we really removed the burden from the operator, and we resulted in smoother snow independent of the operator and changing terrain conditions. So just to sum up, the CMA has a lot of key features. I just touched on a few of them today, but when you look at the mechanics as well as the software algorithms capabilities, we're able to offer precise control maintained for all load conditions. We have very high valve responsiveness. We can offer you a number of flow sharing options when it comes to trying to design your machine for pump saturation. Flexibility and configuration, obviously on the fly, because it can all be done through software. We can do advanced diagnostics, and we can monitor a lot going on with that valve and that hydraulic system. And then we have a reliable performance across a broad temperature range. So we really appreciate your time today. I know that everyone has a very busy schedule, but if you'd like to learn more about this valve, our dynamic machine control, I really urge you to go out to our Eaton website. www.eaton.com/DMC is our dynamic machine control. You'll find a number of really good white papers out there, as well as an overview of our complete Eaton hydraulic offering. And then if you'd like to learn more about the CMA valve, please go to the same location, just change your / to CMA, and feel free to download literature. We've got some really great videos out there and some really nice white papers highlighting some other advanced features of this valve. So with that, I'd like to thank everyone for their time.
All right. Well, thank you, Paul, and thank you, Nadine. All right. We're going to use the remaining time now for questions. And we do have some that have been coming in, but it is not too late to send in your questions. If you see that Q&A box, you can type your questions into there, and they'll come through to us. Question number one, has this actually been released, and where is it made?
We will go. Yes. Thanks, Paul. It will be made in the Havant, UK. That is an Eaton facility in the United Kingdom. It has been, we've had a very soft release. We've launched a number of these to the field in prototype and testing form. Our initial production will go into effect on June 5th. However, I will let you know that we have over 300 sections currently working in the field with over 5,000 hours on 20 different applications. So we feel very confident as we go into our June 6th initial production.
All right. One of our viewers wants to know, with such a technically advanced valve, how is Eaton going to support it?
I think we touched on that a little bit from the standpoint of that ProFX configure. The capabilities to commission it on the machine is done through an app-like type program, as well as the ability to diagnose remotely. You have the ability, if you have a Wi-Fi hotspot, to hook the valve into your computer and bring it online, and it can be viewed by any of our software engineers or engineers on our team who can help people walk through it.
All right, that makes sense. Are there any future models with lower flow going to be available?
Not at this time. We don't plan on going any lower.
Okay. How have you proven its reliability in the field?
Well, in the field, like I said, we have it on 20 different applications. Everything, as you saw in those two applications, on a drill rig to a snow groomer. We have it in some applications with very high vibration. We have it in marine applications, so we have environmental type applications. And like I said, we have over 300 sections currently in the field with over 5,000 hours. So we really feel good about going into our initial production here in June.
Great. Any surprising applications or uses that maybe your engineers didn't think about for this valve when it was first being developed?
Oh, I think, because we take such a problem-solving role with this valve, we've seen a lot of unique applications come our way. Just one example is we're currently working in railroad applications, which was something we never thought to look at, and yet it's a very good valve for some of the application requirements for that. High vibration, precision of, things like when they're tacking. So I think we're just, scratching the surface. We often talk around here, there's probably numerous applications we've yet to realize.
Fair enough. Can one use these valves to combine direction and pressure control? And what might the connections look like? And do you have any connection schematics?
Yes, we can do that. It's the same connections as the cylinder control. And it's all done through the software.
Gotcha.
Paul, if we have a lot of...
Go ahead.
I'm sorry, Paul. I was just going to let you know that if we have a lot of technical questions, I do have the lead engineer, his name is Stephen Smith, in the room with us. So I might bring him in just to make sure that we answer everybody's questions. Okay?
Oh, absolutely. Please. Any idea when you might have product and software education available in Europe?
Product is available currently in Europe, and some of those applications that I talked about, those 20 applications, it's currently running in Europe. I think there's 5 or 6 applications. As far as software education, that's all done through our Eaton ACE Engineer system over there, and we have a number of key people. In fact, there's a couple of them that have went in and really helped customers, so they are available to assist as needed.
Okay. One of the viewers says, how can we integrate the CMA into a machine function analysis, simulation point of view, both controllability and hydraulic prior to field testing?
I'm going to give this one to Stephen because we've been doing some great work on that, so I'll let Stephen answer that one.
Sure. I'm Stephen Smith. I'm not sure if they're referring to modeling. We have black box models that we can provide so that if you'd like to put a model of a CMA valve into a model of your machine, we can provide that.
And what format would that be available in?
Simulink.
Okay. All right, well, that's all the time that we have, or all the questions we have time for, I should say. But if you do have additional questions that come to mind, you are welcome to email those to me directly at pheaney@wtwhmedia.com, and I will be happy to forward them on to the Eaton team to get those answered. Thank you, everyone, for attending this webinar from Fluid Power World and from our sponsor, Eaton Corp. This presentation will be emailed to everyone in the coming days and will also be available at www.fluidpowerworld.com. Thanks once again to Paul and to Nadine for all of their insights, and have a great rest of your day, everyone. Goodbye.
Thank you.